Absolutely wonderful to be here. I'm not used to talking to this kind of audience. I'm a teeny bit nervous, but bear with me in that. Let's see, is this going to happen? Shall I do this? Ah, sorry. Let me, see? Okay, here we go. So I'm going to actually talk to you in 18 minutes, God help me, because I've been doing this for 20 years. How do you do this? Something that you already know. It's all about thinking visually and representing visually. I think that you see that. I think you use it in your own work. My thing here is going to try to encourage you to really take it a little more seriously. So take a look at this. This is a part of a cartoon. Oh, don't look at me, by the way. Only look at the slides. This is the whole cartoon. What this little girl was doing in her own mind was not actually represented, or at least communicated properly. I think this is an incredibly clever idea from Charles Martin. The idea that I'm getting to here is you have to start asking the simple question, what do you want me to see? When you make any sort of piece of representation, any sort of communication, when you're writing, what do you want me to consider? You know, that sounds like, I know what I want you to see. I know what I want you to consider. But don't assume that I'm going to see what you want me to see. This is the biggest problem we have in our laboratories. The researchers just assume that you go right to what they want you to see. And you know what? You don't. Because there's so much to look at. It is the first question you should ask in communication, and I'm going to stick right now to what I know a little bit more about, and that's the visual communication. What do you want me to look at? So this little girl who's trying to show her dancing, showing a flower, which nobody else seemed to get. This is my cheap segue into a picture that I made. Margaret, you're right, photographers make pictures. You're looking right now at a yeast colony. It is quite remarkable. This is a lot of cells of yeast that are talking to each other and forming this extraordinary, beautiful image. Now, look carefully at the screens, because this, in fact, was the picture I initially made. It was the yeast colony growing in a petri dish. I was so blown away by what this morphology was the existence of this amazing stuff, that I decided, look again at the screen, to digitally delete the petri dish. And it did, in fact, make the cover of Science. Now, the idea here is that I made a decision with the researcher, of course, to get you to see what I wanted you to see. This whole small talk is going to be very obvious. The points I'm going to be making are not brilliant. I'm just trying to get it a little higher on your agenda, to start getting serious about things like editing. I'm going to give you a couple of little tools that also are very obvious. I edited out that petri dish. I did not change the science. That's actually incredibly important. I'm not an artist. I'm a person who is representing ideas and content in science. But I didn't change the data in that particular situation. In this situation, look carefully at the screen again, please. You're looking at another amazing thing that's going on here. These are proteus colonies that are growing in this extraordinary pattern. Once again, they're talking to each other. Well, that's another conversation, how this is all happening. Now watch as I want to show you the original image. you see there are cracks in the agar. And for the book that George Whitesides and I did, called On the Surface of Things, we wanted the reader to look at the amazing patterns that these Proteus colonies were growing in. So once again, I digitally deleted it. One can ask, is that allowed? And that's a large conversation we have in science. What is permitted to be fixed, digitally enhanced? By the way, I know I'm totally digital. That's another conversation. I can't believe I have become completely digital, but I am. But anyway, getting to the point is, we wanted you to see the amazing patterns. And so I edited down. We talk in our courses about questioning what is already out there, questioning, perpetuating the way we represent various data. We're getting students to really wonder, is this the way it should be represented? Now, don't get nervous about understanding this. I don't completely understand it either. But this particular image has become iconic in the world of quantum mechanics. You're looking at something kind of remarkable. Has anyone ever seen this before? Ah, no one, wonderful. All right, what you're seeing here are atoms placed on a surface in a corral form. Those are the spikes that you're seeing. Those are atoms. Now, what's going on here is you have to remember that you're not really seeing atoms. You're seeing data that is then represented visually. The researcher, Don Eigler, and his cohorts decided to color it this way. It turns out that what is really important in this image is not only showing the ability to place these atoms in a corral, but in fact what's going on within the corral. What is going on are quantum effects, which I can't possibly describe to you because I don't understand it myself. But what I do understand is that we want to see both the corral and the quantum effects. So Angela DePace and I, who have a book called Visual Strategies, are talking about the overuse of color, for example, and a couple of other things. We're questioning what is already out there, which I hope that you start doing in your representations. In this situation, we think that, we can argue whether this is better or not, but the idea is to talk to each other about how to visually represent ideas. George Whitesides, as most researchers typically just show off as many pictures as they can for an NSF proposal. And what we're suggesting is try to get some order to this. Question the already used, throwing ideas out, and for this image we organized it in terms of scale. And we actually have a legend on the side instead of just putting those little ABCs all over the place that really it's impossible to look at. We talk about using metaphor, which is incredibly, incredibly powerful, and that's where my whole head is these days. A very powerful way of explaining ideas. Again, you know that. I'm not saying anything new to you. I'm just trying to encourage you to incorporate it more visually in the way you talk to your audience and, by the way, talk to each other. So, for example, I took this picture of an AFM tip. There's an instrument called an atomic force microscope where you can see what you actually cannot see. Because things are so small that you cannot see it optically. So you have to see it, the surface of things, by, in this case, using a tip that will measure the force from the surface and the tip. And we're trying to create a metaphor in the book to describe how an atomic force microscope tip works. You know, this pin art. You know, when you hundreds of these pins, and when you place it against something, it literally feels what the surface is like. Well, that's how an AFM microscope works. Hopefully we're sort of touching on explaining it with this metaphor. But metaphors always fall apart, and that's something else that I hope I get to in a minute. In the book, another metaphor is, what do we mean by binary? So we decided to use the inside of a music box. The notes either go on or off, on or off. That is not a brilliant metaphor, but enough to sort of get a handle on what the whole notion of binary, where most of our computers, unless you get into quantum computing, which I'm not going to touch, but it is an interesting metaphor. And by the way, the idea of coming up with a metaphor is in itself a fabulous exercise. Where is it wrong? Where does it grasp the real idea? We asked students, for example, can you explain Brownian motion to a high school student? Here's one that somebody came up with, bumper cars. It's actually very clever, but it's a little wrong. And we're not going to get into that now. But again, the thinking of metaphors and visually representing it metaphorically could be incredibly exciting. Can you explain particle in a box? And this is what somebody came up with. Very clever, but not quite right. Again, the conversation about visual metaphors can be an incredibly powerful tool. Again, what has the higher boiling point? Take a real good look at this. I'm not going to get into the chemistry, but what I do want to get into is the fact that this MIT student could not explain it properly in this drawing. This drawing is dead wrong. And what we have found is that this exercise is a very powerful way of seeing your misconceptions. Something that you might want to do in teams, for example. This whole notion of drawing together. That's what I'm getting to here. And by the way, I don't draw, but I sure see the value of it. And what we're getting to additionally is drawing collaboratively, which I was watching in other presentations. And Margaret was drawing on her, in her presentation, that whole simple process of showing someone as we draw together. In this particular case, we had design students and science students drawing together and teaching each other. It's absolutely fascinating and simple, and by the way, cheap. I am absolutely convinced that all this stuff clarifies your understanding of concepts and all sorts of ideas. And it can, in fact, this notion of collaborating and thinking visually can be innovative. Look what happened to Darwin, a simple idea of drawing what his observations were. It changed our lives. Notice that he says on top here, I think. It's very powerful. I'm going to end with a case study. 62-year-old thoracic surgeon is lifting weights, comes down with an excruciating pain. He knows immediately he's had an aortic dissection because he's a chest surgeon. In the ambulance, he speaks to the people in the OR, in the emergency room. This is not a heart attack. This is a type 2 DeBakey aortic dissection. Turns out it was a type 3. He knew in his agony. Smart guy. The doctor sits down with the wife and family and starts to try to explain with a drawing what in fact is going on here and what will be going on. This is a drawing that the team of doctors drew, a part of it. because I want to show you the process. So you see that little X is where the dissection began, goes down to the aorta, creates a true and false lumen, which is what eventually they're going to be looking for through the next couple of years, and puts in all of these stents to get this guy to survive. I put these arrows in so you could see where all those stents were. Actually, it turns out there were 11. Also, the doctor had to, of course, label everything, which we could edit out the labeling, I think. I'm not sure the wife necessarily needed to see all those labels. This drawing is different from what I took off of the Mayo Clinic website. This is probably part of an animation. And I'm not saying that having somebody else visualize your work is not important. I think it is. It's clean, it's interesting, but it doesn't come close to the drawing that was taking place between the patient's wife and the doctor. This was, again, the final drawing that happened. The experience between the doctor and the wife was unbelievably intimate. It was personal. There was a give and take. The doctor was taking her through the situation. I was the wife. I didn't think this was going to happen. It was very important for me to see and learn what was going on here. It clarified my understanding, and it helped in shared decision-making. The crazy part about all this is that Ken eventually got cancer. It was nuts. 2 years after the dissection, they found a cancer. They were monitoring his aorta, and that's the absurdity of all this. But what I'm getting at is that intimacy that happened between me and that physician was memorable, and I know it sounds crazy to say, but it made it slightly more tolerable. It can be an incredibly personal and helpful thing to do. So whether you're a physician or a nurse or team leader or anybody, I don't know who you all are, but I am promising you that there is unbelievably fabulous and probably very useful ideas in the power of visual communication. Thanks.